Today we're going to be talking about mixtures, compounds, and elements. And by the end of this, I would like you to be able to explain what each of these are and the difference between them. So, matter. This is anything that has mass and takes up any kind of space. So, it could be the computer in front of you, the keyboard you're typing on, the drink you have next to you, the chair you're sitting in. It's anything and everything that has some kind of mass and takes up any kind of space. So some classifications of matter. We've got mixtures and pure substances here. Mixtures, these are physical combinations of two or more pure substances. And pure substances, this is matter that has a fixed composition and definite properties. Pure substances, these are elements and compounds. You may already know some information about these, which is great. On the left picture there, these are different elements. We've got magnesium and selenium and sodium and copper. And on the right there, we have a molecule of water, which is 2 parts hydrogen to 1 part oxygen. Elements. These cannot be broken down any further by chemical or physical means. They are as small as they can get. And an atom, this is the smallest unit of an element in order to still retain its properties that it has. Compounds, these are made up of atoms of different elements and are chemically combined. So if we go take a look back at this molecule of water here, we have 2 atoms of hydrogen to 1 atom of oxygen that makes up this molecule of water. And molecules are the smallest unit of a compound in order to retain its properties. So, like I have been saying, 2 atoms of hydrogen to 1 atom of oxygen make up 1 molecule of water. So the properties of compounds are different than the elements that make them up. So if you think about, again, those 2 atoms of hydrogen and that 1 atom of oxygen, hydrogen and oxygen at room temperature are in the gas phase. You have them floating around you right now. But when we chemically combine them and turn them into water, they are now at the liquid phase at room temperature. So this just shows that the properties are different when they become a compound. And you can separate compounds up by chemical means. We could stick some electricity in some water, and we could separate the hydrogen and the oxygen and turn it back into gas again. I do not recommend doing that right now. It should be done in a lab setting, very controlled, but it is possible. Mixtures. These are a physical combination of substances, like we've talked about, and they can be separated. There are 2 different types of mixtures. We've got heterogeneous and homogeneous. Heterogeneous mixtures are mixtures with different parts that have different properties. These, you can see each individual part of this mixture, like the pizza on the top there. You can tell that it has cheese and sauce and crust and olives and tomatoes. And the salad down there, you can tell that there's cantaloupe and strawberries and blueberries and grapes and all kinds of things in there. Granite and blood are other examples of heterogeneous mixtures as well. And then we have the homogeneous mixtures. These are mixtures that have properties that are uniform throughout the whole entire mixture. So you cannot pick out what is in that mixture just by looking at it. So like your pop there, you could not tell that it is made up of sugar and some kind of syrup and flavoring just by looking at it. I mean, you could read the ingredients on the can and figure that out, but by looking at it, you couldn't figure that out. Another one is air. You can't tell that you've got carbon dioxide and nitrogen and oxygen bouncing around in your head, on your head, or your body, or in your room, but they're there. So which is which? If you're looking at the periodic table, you can tell that each one of these is an element and they all have one symbol. It has one capital letter. Some of these, if we go back and take a look here, some of these have a capital letter and a lowercase letter, but you notice that they only have one capital letter. So that means it's an element. Compounds, these are a formula. They have more than one symbol and have more than one capital letter. And most of them end in ic, ate, os, or ide. So if I wanted to talk about sodium chloride, it is made up of sodium and chloride. And the symbol is a capital N, lowercase a, capital C, lowercase l, and when I say it as a whole, sodium chloride, the very end of it ends in ide, I-D-E. So that is a way to identify whether it's an element or a compound. Mixtures, these contain more than one ingredient. You can either see them or you cannot. Be warned, water is considered an ingredient. So if it says it's a solution of sodium chloride and water, or a saltwater solution, that means it is a mixture. Or if it says there's a certain percent of a pure substance, this means it's a mixture. So if you were to go into your bathroom and take a look at the isopropyl alcohol you may have in there, or the hydrogen peroxide, you would notice there is a percent on there. Isopropyl alcohol may be at about 70%, or 80 or 90. Those are the three that you can buy. That means there's 70, 80, or 90% alcohol in that mixture, and the remaining percentages are made up of water. Your hydrogen peroxide, typically you buy it at about 3% at home, and that means it's made 3% up of H2O2, which is hydrogen peroxide, and 96% water. So be on the lookout for those because it is very, very important. So in order to separate mixtures, there's many different methods to do it, and it would all kind of depend on the mixture you're dealing with. You could do it by filtration, distillation, chromatography, crystallization, or sublimation. So filtration would be if you've got a solid mixed in with a liquid. Distillation would be if there's two liquids mixed together, like your isopropyl alcohol. You could separate the two out by their boiling points. Chromatography, if you've ever done this, you can figure out the different colors of ink that make up your pen just by using a chromatography plate. So things to remember from this lesson would be elements, they have one symbol having one capital letter, and they can be found on the periodic table. Compounds, they have two or more symbols with two or more capital letters, and as a compound you cannot find it on the periodic table, but you can find the elements that make it up. Mixtures, these contain one or more ingredient in them. They can be indicated as a percentage of a pure substance or considered a solution. So this concludes this lesson today. Don't forget to go do the worksheet and the lab, and good luck.